If you find this video helpful, then feel free to donate whatever amount you can. Link is in the description below. Find I, I1, I2 and power factor of the circuit in figure and also draw complete vector diagram. So this is the circuit diagram. We have to find this current I, this current I1 and this current I2. And also we have to draw the vector diagram for this circuit. Solution. First of all, we will write what is given, or first of all we will redraw the circuit. Now here we can see, let's say this is Z1. So this one is Z1. Let's say this is Z2 and let's say this is Z3. This is impedance Z1, this is impedance Z2 and this is impedance Z3. Now first of all we will find total impedance. So total impedance is equal to Z and it is equal to Z is equal to, here we can see Z1 and Z2 are connected in parallel. So Z1 parallel with Z2 and both are in series with Z3. So plus Z3. So now this will be Z1 into Z2 divided by Z1 plus Z2 plus Z3. Now here we will substitute all the values. The value of Z1 is 6 plus J8, 6 plus J8 in one bracket, and in another bracket the value of Z2. The value of Z2 is 4 minus J7. 4 minus J7 divided by 6 plus J8, then plus the value of Z2 is again 4 minus J7 plus the value of Z3. The value of Z3 is 3 plus J5. 3 plus J5. Now if we solve this, so it will be, first of all we will solve the numerator. Now here we can see it is in rectangular form, but for multiplication we need this in polar form. So it will be under root of 6 square plus 8 square at an angle of tan inverse of 8 by 6. 8 by 6. So this will be in one bracket. Then in second bracket it will be under root of 4 square minus 7 square. 4 square plus minus 7 square. Then at an angle of tan inverse of minus 7 by 4. Bracket complete. Divided by, now this will be 6 plus 4 will be 10 and J8 minus J7 will be only plus J. Plus J. And this will be plus 3 plus J5. Plus 3 plus J5 as it is. Now this will be 6 square plus 8 square under root of 6 square plus 8 square. So it is 10. 10 at an angle of tan inverse of 8 by 6. Tan inverse of 8 by 6, it is 53.13. 53.13, and this will be under root of 4 square plus minus 7 square. It is 8.06. 8.06 at an angle of tan inverse of minus 7 by 4. It is minus 60.25. Minus 60.25 degree. Here also it is degree, divided by 10 plus j. Then plus, here this will be plus 3 plus j5. So if we simplify this, so this will be 10 into 8.06. So it will be 80.6 at an angle of 53.13. Then this will be plus minus 60.25 divided by. Now we also have to convert this rectangular form to polar form. So it will be under root of 10 square plus 1 square at an angle of tan inverse of 1 by 10. Then plus 3 plus j5 as it is. So it will be 80.6 at an angle of, now this will be 53.13. Then this will be plus minus 60.25. So it is minus 7.12. Minus 7.12 divided by, now under root of 10 square plus 1 square. So it is 10.04. 10.04 at an angle of tan inverse of 1 by 10. 5.71. 5.71 plus 3 plus j5. Now we will solve this. 80.6 divided by 10.04. 10.04. It is 8.02. 8.02. 8.02 at an angle of, now this will be minus 7.12 minus 5.71. Then plus 3 plus j5. So this will be 8.08 at an angle of minus 7.12 minus 5.71. So it is minus 12.83. Minus 12.83. Then plus 3 plus j5. Now we have to solve the addition of this. So first of all we have to again convert this polar form to rectangular form. So it will be 8.02 cos minus 12.83 plus j sin j 8.02 sin minus 12.83. So this is the formula to convert polar form to rectangular form. R cos theta plus j r sin theta. So here the value of r is 8.02. Now remaining part as it is, plus 3 plus j5. So it will be 8.02 cos minus 12.83. It is 7.81. 7.81 plus j. Now this will be sin, in place of cos it will be sin. It is minus 1.78. Minus 1.78 plus 3 plus j5. Now we will solve the real part first. So 7.81 plus 3, 7.81 plus 3, so it will be 10.81, 10.81, then this will be minus 1.78 plus 5, minus 1.78 plus 5 will be 3.22, 3.22. So this is the value for total impedance Z. Now it is in again rectangular form. We can further convert this into its equivalent polar form. So it will be under root of 10.81 square plus 3.22 square at an angle of tan inverse of 3.22 divided by 10.81. So it will be under root of 10.81 square plus 3.22 square. So it is 11.27. 11.27 at an angle of tan inverse of 3.22 divided by 10.81. It is 16.58. 16.58. So this is the value of Z in polar form. 11.27 at an angle of 16.58 degree, and its unit will be ohm. Now what we have to find? We have to find the value of current I. Now we have the value of total impedance Z and voltage V. So we can find the value of I. So therefore I will be equal to V upon Z. The value of voltage is 230 at an angle of 0 degree. 230 at an angle of 0 degree divided by impedance value is 11.27 at an angle of 16.58 degree. So it will be 230 divided by 11.27. So it is 20.40. 20.40 at an angle of, this will be 0 degree minus 16.58. So it will be minus 16.58 degree. So this is the value of current I, and its unit will be ampere. Now we have the value of current I. Now next is we have to find the value of power factor. We can find the value of power factor because here we can see this is the value of angle phi. Phi is the difference between voltage V and current I. So it is minus 16.58. So we can say cos phi is equal to cos of minus 16.58. So cos of minus 16.58 is 0.958. 0.958. This is the value of power factor cos phi, 0.958, and power factor have no unit, 0.958. Now next is we have to find the value of I1 and I2. We have already found the value of current I and power factor. Just I1 and I2 values remain, and we have to draw the vector diagram after that. So now we will find the value of I1. So to find the value of I1, we will use current division rule. To find I1, use current division rule. Now, according to current division rule, I1 is equal to total current I multiplied by, here we can see I1 is equal to total current I multiplied by opposite branch impedance divided by total impedance. So opposite branch impedance is 4 minus J7 4 minus J7 divided by total impedance. Total impedance will be this value 4 minus J7 plus 6 plus J8. 4 minus J7 plus 6 plus J8. So this will be the value of current I1. The value of current I is 20.40 at an angle of 20.40 at an angle of minus 16.58 minus 16.58 degree multiplied by 4 minus J7 divided by this value. So first we will solve this. So it will be 4 plus 6. So it will be 10. And this will be minus J7 plus J8. So it will be plus J only. Now this is in rectangular form. This is also in rectangular form. We will convert this into its equivalent polar form. So it will be 20.40 at an angle of minus 16.58 multiplied by under root of 4 square plus minus 7 square divided by at an angle of tan inverse of minus 7 by 4 divided by under root of tan square plus 1 square at an angle of tan inverse of 1 by 10. So this will be 20.40 at an angle of minus 16.58 multiplied by, this will be under root of 4 square plus minus 7 square is 8.06. 8.06 at an angle of tan inverse of minus 7 by 4. So it will be minus 60.25. Minus 60.25 divided by, now this value again. So it will be under root tan square plus 1 square. So it is 10.04 at an angle of, now this will be tan inverse of 1 by 10. 5.71. 5.71. So this will be 20.40 at an angle of minus 16.58 multiplied by, now we will solve this directly. So this will be 8.06 divided by 10.04. So it is 0.802. 0.802 at an angle of, now this will be minus 60. Minus 60.25, then minus 5.71. So it will be minus 65.96 degree. So this will be in one bracket and this will be in another bracket. Now we will multiply this 20.40 into 20.40 multiplied by 0.802. So it will be 16.36. 16.36 at an angle of minus 16.58, and it will be added to plus minus 65.96. So it is minus 82.54, minus 82.54 degree. So this is the value for current I1. I1 is equal to 16.36 at an angle of minus 82.54 degree, and its unit will be ampere. Then next we have to find the value of I2. So I2 will be equal to, here this is the value of I2, and I2 will be equal to total current I multiplied by opposite branch impedance, that is Z1, divided by Z1 plus Z2. So this will be the value of I2. We will copy it from here. So this will be the value of I2. Now we will substitute the value of current I. The value of current I is 20.40 at an angle of minus 16.58. 20.40 at an angle of minus 16.58. Minus 16.58 degree multiplied by Z1. The value of Z1 is, here we can see the value of Z1 is 6 plus J8. 6 plus J8 divided by Z1 plus Z2. Now here also we can see that in case of I1, we have already calculated Z1 plus Z2. Here this is Z1 plus Z2. So the final answer for Z1 plus Z2 is this value. This is the value for Z1 plus Z2 in polar form. So we will write this as it is. Now again we will simplify this. So first of all, we will simplify this part. This 20.40 divided by 10.04. So it will be 20.40 divided by 10.04. So it is 2.03. 2.03 at an angle of, now this will be minus 16.58 minus this will be 5.71. So it is minus 22.29. Minus 22.29. This will be multiplied with this value. Now again this is in rectangular form. So we have to convert this into its equivalent polar form. So it will be under root of 6 square plus 8 square at an angle of tan inverse of 8 by 6. So this will be 2.03 at an angle of minus 22.29 multiplied by under root of 6 square plus 8 square. So it is 10 at an angle of tan inverse of 8 by 6. So it is 53.13. 53.13 degree. Now we have to multiply this 2.03 into 10. 2.03 multiplied by 10. So it will be 20.3. 20.3 at an angle of, now this will be minus 22.29. Minus 22.29. It will be added with this 53.13. So it will be 30.84. 30.84. Now since it is current I2, so its unit will be ampere. So therefore I2 is equal to this value. Now we have the value of current I, current I1 and current I2. We also have the value of voltage. So we can draw the vector diagram. Now to draw the vector diagram, we will take voltage as a reference because its angle is 0 degree. Here we can see the angle of voltage is 0 degree. So we will take voltage as a reference. So here this will be the voltage V is equal to 230 degree at an angle of 0 degree, or we can write 230 degree only, 230 volts. Then next is current. The value of current is 20.40 at an angle of minus. So it will be downside 16.58. So here this will be the current. This current will be I is equal to 20.40. 20.40 at an angle of minus 16.58. Minus 16.58 is the angle phi. 16.58. Now here this will be positive because we already taken it in downside. So it is lagging. This current is lagging the voltage by 16.58. Then next we will draw I1. So I1 is equal to 16.36 at an angle of minus 82.54. So it will be like this, 16 point, and it is 82 degree. So it will be like this, and this will be 82 degree. This angle is 82.54 degree. 54 degree in minus. Minus means downside. And this is current I1, and its value is 16.36. 16.36 ampere. Also its unit will be ampere. Then I2. Here we can see I2 is equal to 20.3, and its angle is positive. So it will be on upper side. So it will be 20 point. I2 is equal to 20.3 ampere, and its angle from this voltage will be 30.84 degree. This angle is 30.84 degree. So this is the vector diagram. This is the vector diagram for this question. I1, I2, and I, and this angle is phi. This angle is for I2, and this angle is for I1, and this is voltage V is equal to 230 volt. If you find this video helpful, then feel free to donate whatever amount you can. Link is in the description below. Thank you.